Bismillahirrahmanirrahim. Dear students, today we will discuss about projection, that what is projection, type of projections, and then we will discuss something about projection of points. So let's start with projection. So basically by projection we means a method that is used to describe shape by the process of causing an image to be formed by rays of sight taken in a particular direction from an object to a picture plane. The meaning of this definition is that if you have an object, let's take the example, this is an object and you are taking the rays of light that is originating from object and that is hitting a plane, and this plane is known as picture plane. So rays of light originating from object and hitting this picture plane and projected on that. Now, by joining these points sequentially, you can get the image. So this process is known as projection. So let's go back to the definition. So it's a method to describe shape by the process of causing an image to be formed by rays of sight taken in particular direction from an object to a picture plane. So in this example, we have seen that this is the object, this is the picture plane, these are the rays of sight. These reds are the rays of sights and they are originating from the objects and hitting the picture planes. These red lines which are originating from object and hitting these planes are known as projectors. So these are the projectors. These lines are projectors. Whenever these projectors hit the picture planes, so we will get different points. So by joining these points sequentially, let me zoom it. So by joining these points in a sequent manner, okay, so you will get the image of this object on that picture plane. So this process is known as projection. You can see in different example that these are the objects and these are the rays of sights originating from object and hitting the plane. So these red lines are known as projectors and this plane is known as picture plane, and the image that is formed on the picture plane is known as projections. This process is known as projection. So again, projection is a method to describe shape by process of causing an image to be formed by rays of sight taken in a particular direction from an object to a picture plane. So this process is known as projection, or the object that is formed by this process is known as projection. There are three types of projections. The first one is orthographic projection, the second one is oblique projection, and the third one is perspective projection. So let's see. The first one is orthographic projection. So in this orthographic projections, if the rays that are originating from objects are perpendicular to the picture plane, the projection is known as orthographic projections. The second one is oblique projections. So if the rays are at angle to the plane, the projection is known as oblique projections. And if the rays are taken to a particular station point, the projection is known as perspective projection. So we have three types: orthographic projection, oblique projection, and perspective projection. So I will try to convey this definition with the help of diagram. So in this first type, orthographic projection, we have told you that orthographic projection is that type of projection in which the rays that are originating from object and hitting the picture plane is perpendicular. Then the image form will be known as orthographic projection. You can see in this example all these projectors that are originating from object that are hitting this picture plane perpendicular. So you can see, we can zoom it as well. So in this example, you can see this is the example of orthographic projection. So you can see these projectors are perpendicular to this plane. And the one more thing is, if these rays are perpendicular to this picture plane, so all these projectors will be parallel to each other. So again, orthographic projection is that type of projection in which projection is formed due to the projectors that is perpendicular to this picture plane. So the image form is known as orthographic projections. Now in oblique projection is that type of projection in which the rays of sights are projectors that are at angle to this to this picture plane. So the image form will be known as oblique projection. So you can see in this example that this plane is now at certain angle to these objects. So these rays are acting on this plane and making a certain angle with this plane. Clear? So this type of projection is known as oblique projection. The third one is perspective projection. In perspective projection, you have a screen, you have a source point. For example, if you are standing here and you are looking at this part, so definitely the rays of sight will originate from this and they will strike with the edge and then hit the picture plane. So this type of image form will be known as perspective projection, because you are looking the object from a source point, from a single source point. All the rays are originating from these source points and they are striking this plane, and by joining every point, projected point, in a sequence manner, so you will get the shape that is projected. That is projection. So this type of projection is known as perspective projection. The simple thing I will again repeat: in orthographic projection, these projectors are perpendicular to the picture plane and the image form will be known as orthographic projection. The second one is oblique projection, in which these projectors are at certain angle to this picture plane, making this projection, and this is known as oblique projection. In perspective projections, the projectors are rays of sights are taken from a single point, single source point. Okay, and these source points and the rays that are originating from these source points are hitting the picture plane and the image will be formed. So this type of projection is known as perspective projection. So okay, so let's start with principal plane of projection. While you are defining the projection, we know that there must be a plane of projections where the image can be formed. So we will talk about those planes. So basically we have two principal planes. There are two principal planes, the rest are auxiliary planes. So two principal planes are horizontal plane and vertical plane. So you can see in this image, if I enlarge it, so you can see this is horizontal plane and this is vertical plane. Clear? So when this horizontal plane and vertical plane intersect each other, so it will make four quadrants: first quadrant, second, third, and fourth. So this is a vertical plane and it is represented by VP, and this is horizontal plane and it is represented by HP. Clear? So we have four quadrants: first quadrant, second, third, and fourth. Now remember that when this horizontal plane and vertical plane intersect each other at 90 degree, so there will be a line of intersection. Clear? So this is known as reference line, or we can say this is XY line. So let's talk about vertical plane. Now vertical plane is used for projection of front view, and horizontal plane is used for projection of top view. Now what is front view? It means that, for example, this is the object and you are looking from this station. Clear? So the object, the image that will be formed is known as frontal view because it is in front of you or the object. Similarly, if you are watching the object from the top, so the image will be formed is known as top view. So that image which you are watching from the front is known as frontal view, and the image that you are watching from the top is known as top view. So remember that you should remember that vertical plane is used for projection of frontal view. Always frontal view will be on vertical plane, and horizontal plane is used for projection of top view. We will see in next few slides that how it will be formed frontal view will be formed on vertical plane and how the top view is formed on horizontal plane. Now the horizontal plane and vertical plane intersect each other at right angle and create a line of intersection that is known as reference line. So this is a vertical plane and this is horizontal plane, and they are intersecting each other at 90 degree and forming this line. Now this line is known as XY line. This intersection also creates four quadrant, which I have already told you. This will be the first quadrant, this will be the second, this will be third, and this one will be the fourth quadrant. Okay, so let me start with projection of point. So before going into the projection of the type of projection, first we will discuss what is mean by projection of points. For example, if you have these planes and the point may lies anywhere in the fourth quadrant, so how you will be able to project them on this vertical plane as well as horizontal plane. So we will discuss that. Clear? Okay. There are certain conventions that are related to projections of points. For example, the actual point in space is denoted as uppercase letter. So if you have given any point that is anywhere in any quadrant, that will be represented as uppercase. We will see the example in next few slides. So the actual point in space is denoted as uppercase letter, and the front view is denoted as a lowercase letter with a prime, and top view as a lowercase letter without a prime. For example, what does it mean? It means that if you have a point, that now this is a point A. You can see this is a point A. The actual point is represented with a capital letter. And if we project this point on this plane, that is vertical plane, and you are watching the point A, and you are standing over here. So what if you project this point on this plane? So you will get another point. So this point is projected on this vertical plane, and the point that is projected on vertical plane show you its frontal view, and it is represented with small letter with a prime. So frontal view is represented with a small letter with a prime, and the top view will be over horizontal plane. So the top view will be projected over here, and we will see that this top view that is projected will be presented with a small letter. So if actual point is A, then its frontal view is marked as A prime, and its top view is marked with a simple small letter A. So the intersection of two principal plane, i.e. horizontal plane and vertical plane, is a straight line. That is already told you that this line is a reference line and shall be denoted as XY line. So this is a reference line and it should be marked as XY line. Okay, so Let's start with projection of points. A point that can be situated anywhere in three-dimensional space relative to two planes of projection. You have seen the two plane of projection, horizontal plane as well as vertical plane. Now this point can be situated anywhere in three-dimensional space. That point may be in first quadrant, that point may be in second quadrant, third quadrant, or fourth quadrant. The point may lie in horizontal plane as well as in vertical plane, or it may be in horizontal plane or it may be in vertical plane. So we will talk in this slide, we will talk about these things. So if you have a point with reference to HP or with reference to VP, there can be many combinations. The point may be above the horizontal plane. So for example, this is a first quadrant, this is second, this is third, and this is fourth. So point may be in first quadrant, it may be above horizontal plane, it may be in front of vertical plane, it may be in behind the vertical plane, it may be below the horizontal plane over here, and it may be behind the vertical plane. So there are many combinations, and we will discuss these things in details. So with reference to horizontal plane, it can be above the horizontal plane, it can be below the horizontal plane, or it may be within horizontal plane. And same case is with reference to vertical plane. The point may be in front of vertical plane, the point may be behind the vertical plane, or the point may be within. Now we have reference to a point with reference to horizontal plane and a point with reference to vertical plane. So we have three combination over here and three combination over here. So we can also combine that a point may be above horizontal plane and in front, it may be in front of vertical plane. This will be the example that, for example, this is the point. This is above the horizontal plane and in front of vertical plane. Similarly, a point can be above the horizontal plane and behind the vertical plane. For example, so if the point is located here, so it will be above the horizontal plane and behind the vertical plane. Similarly, a point may be above the horizontal plane and within vertical plane. For example, if the point is over here, the cursor which is, so it means that this is above the horizontal plane and the point is within the vertical plane. Similarly, the point can be below the horizontal plane and in front of vertical plane. We will see all this example in coming slides. So the point is behind the below the horizontal plane and in front. So the point can, for example, this point is over here, the cursor. So this point is in front of vertical plane and below the horizontal plane. So these are all the combination. We will see all the example in these coming slides. So with reference to horizontal plane, these are the same thing which we discussed in previous slides. So 9 possible position with respect to two reference plane can be. So if a point is above the horizontal plane and in front of vertical plane, so it will be in first quadrant, and that is known as first angle. There, this is the example of a point in above the horizontal plane and in front of vertical plane. So the point is in first quadrant, that is known as first angle. Similarly, a point may be above the horizontal plane and behind the vertical plane. So this will be the second quadrant. The example is the point. If the point is over here, so the point may be the point is above the horizontal plane and behind the vertical plane. So this is the example, and it lies in the second quadrant. So that is known as second angle. The point can be above the horizontal plane and within vertical plane. So that will be the boundary of first angle and second angle. We will see all these examples in coming slides. So don't worry about this. Similarly, a point can be below the horizontal plane and in front of vertical plane. That is fourth angle. For example, if the point is here, So it is below the horizontal plane and in front of vertical plane, and also it lies in fourth quadrant, that is known as fourth angle. Similarly, a point below horizontal plane and behind the vertical plane, that is third angle, and so on. So let's start with the examples. So the point above the horizontal plane and in front of vertical plane, this is a point A. This is the point A and it is represented as capital letter. So you can see that this point is above the horizontal plane and in front of vertical plane. So that is why it is in first quadrant or first angle. So if you project this point on this vertical plane, you will get a point that is its frontal view, which is represented by A dash. Similarly, a point above the horizontal plane and behind the vertical plane. So this is the case. Now this point is behind the vertical plane and above the horizontal plane. So this is the second scenario. Again, you will, if you project this point on this vertical plane, you will get another point, that is the projection of this actual point A, and this projection is represented with a small letter with a prime, showing that it is the frontal view of this point A. The third case is point above horizontal plane and within vertical plane. So you can see that this point is in vertical plane and this point is above the horizontal plane. So this was the third scenario. So what we conclude from all these examples, whether this, or whether this. So conclusion is that if a point is above the horizontal plane, its front view is always above XY line. So you can see in this example, this point is above horizontal plane. So in this scenario, its frontal view is above the XY line. Similarly, in this example, its frontal view is above XY line. And in third scenario, the frontal view is again above the XY line. So that was the conclusion. If a point is above the horizontal plane, its frontal view is always above XY. Now let's move forward. Now you can see that point below the horizontal plane and in front of vertical plane. Now this point is below the horizontal plane and in front of vertical plane. So you can see now its frontal view is on this vertical plane. This point is actually projected on this vertical plane and the projection form is represented by A dash. So you can see this point is in fourth quadrant because it is below the horizontal plane and in front of vertical plane. So this is the scenario. And you can see that this now here, the projection, the frontal view is below the XY line. Similarly, this point can be below the horizontal plane and behind the vertical plane. Now you can see this point is in third quadrant and this point is below this horizontal plane and behind this vertical plane. So again, if you project this point on this plane, so you will get the frontal view of this point. And again, this point, this frontal view is below the XY line. The sixth scenario is the point is below the horizontal plane. You can see this point is below the horizontal plane and within the vertical plane. So this point is in vertical plane and below the horizontal plane. So in this scenario, again, the frontal view will be the same point and it is represented with A dash. And this frontal view is below the XY line. So we will draw a conclusion that if a point is below the horizontal plane, its front view is always below XY line. In first scenario, we have seen that if a point is above the horizontal plane, any point that is above the horizontal plane, so its front view will be above the XY line. And in the second one, if a point is below the horizontal plane, its front view is always below the XY line, like in these three examples. The point is below the horizontal plane, so their frontal view will be below the XY line. Now we will move towards seventh scenario, the point within the horizontal plane and in front of vertical plane. So you can see that this point A is in horizontal plane, but it is in front of vertical plane. So you can see that if you project this point on this vertical plane, so its projection will be represented as A prime, and this projection is now on XY line. Again, point can be within horizontal plane and behind the vertical plane. So you can see now this point is in horizontal plane, but it is behind the vertical plane. So if again you project this point on this plane, so the frontal view will be formed on XY line. The ninth scenario, the point may be in horizontal plane as well as in vertical plane. So if someone asks to show you a point that can be within horizontal plane and within the vertical plane, so this is the good example. Now you can see this point is on XY line, meaning it means that this point is in horizontal plane as well as in vertical plane. And if you project, you will get the same point on XY line, which is represented by a bar. So we will draw the third conclusion, that if a point that lies within horizontal plane, its view will be always in XY line. Now let's the position of frontal view of point with respect to XY line is dependent on its position with respect to horizontal plane. We have already discussed that the position of frontal view of any point depends on its position with respect to horizontal plane. I will repeat again, if a point is above the horizontal plane, its frontal view will always above the XY line. If a point is below the horizontal plane, its frontal view will be below the XY line. And if a point is within the horizontal plane, then its image will be formed on XY line. So the distance of frontal view of a point from XY line is the same as distance of point from horizontal plane. Now what does it mean? So you can see in previous example, in this first example, the distance of frontal view from XY line is the same as this point from the horizontal plane. So for example, if this point is 10 millimeter above the horizontal plane, so in frontal view you will draw its frontal view above 10 millimeter above the XY line. Similarly, if this point, for example, this point, if this point A is 10 millimeter below the horizontal plane, so again the frontal view will be below 10 millimeter below the XY line. These things will be clear to you in next few slides. So now take the example, now take another scenario. The point in front of vertical plane and above the horizontal plane. So this point is in front of vertical plane and above the horizontal plane. So you can see that the top view will be on horizontal plane. Okay, before going to next slides, let me tell you one thing, that when this horizontal plane and vertical plane, they intersect each other at right angle, so you will get 4 quadrants. The first quadrant, the second quadrant, the third quadrant, and fourth quadrant. Now the first quadrant is first angle, the second quadrant is second angle, and the third is third, and the fourth one is fourth angle. So remember one thing, that we can rotate this horizontal plane in such a way that it coincides with vertical plane. Why we rotate? I will show you in a few moment of later that. But remember now at this point that this horizontal plane can be rotated and can be aligned with vertical plane, such that this second quadrant and fourth quadrant collapse. Clear? So we have first and only third quadrant there. So that's why we will also study in our next lectures the first angle projection and third angle projection. You will never see the second angle projection and fourth angle projection. Only we have first angle projection and third angle projection. The reason is that if we rotate this horizontal plane, it will collapse with vertical plane, or it will be aligned with vertical plane. So the second and fourth quadrant will be finished. Okay, so why we rotate this horizontal plane such that this second and fourth quadrant diminish? The reason is that whenever you have been asked to draw the projection of any point, line, or anything, so you have to draw it on a paper page which is two-dimensional. Okay, so in real you cannot easily draw this projection on three-dimension space, because you have to present it on a page that is two-dimensional. So you have to represent all its view on two-dimensional page or paper. So that's why for this they rotate. For your understanding purpose, they will show you that this horizontal plane is rotating and aligning with vertical plane, because you will see in next example that we will also have some projection on these horizontal planes. So if you rotate them, the top view and front view will align with each other above or below with respect to each other. So now we will see this example. So the point is in front of vertical plane and above the horizontal plane. So this point A is in front of vertical plane and above the horizontal plane. So you can see, if you are looking this point from the top, so definitely its image will be formed on horizontal plane. And this image or this projection of point is represented by a small letter. This small letter represents that this is the top view of this point. So now in this case, if you rotate this horizontal plane such that it coincides with the vertical plane, so you can see that if you rotate this plane, so this top view will lie below the XY line. So if you have a page and you want to draw its top view and front view, so you have to rotate this plane. In next example, you can see that this point is below the horizontal plane and in front of vertical planes. So again, if you are watching this point A from the top, so you will get the projection of A on this point on horizontal plane. But if you rotate this horizontal plane such that it coincides with vertical plane, so the top view will be below the XY line. The third example is the point is in horizontal plane, but it is in front of vertical plane. So again, if you are watching it from the top, so definitely you will get the top view in the horizontal plane, and upon the rotation, the top view will be below the XY line. So conclusion, if a point is in front of vertical plane, but it is below, if a point is in front of vertical plane, so its top view will be always below XY line. These are the some points that you must understand or you must memorize. So if again, I will repeat the previous one. If a point is above the horizontal plane, its front view will be above the XY line. If a point is below the XY line, so its frontal view will be below the XY line. And if a point is within horizontal plane, its frontal view will be on XY line. Now, in this case scenario, when the point is in front of vertical plane, so its top view will always below the XY line. Now, this is another scenario. Now, this point is behind the vertical plane and above the horizontal plane. You can see this point A is behind this vertical plane, but it is above the horizontal plane. So is in this scenario, if you are watching it from here, so its frontal view will definitely, its frontal view will be this point A dash, and its top view will be this. So if you rotate this, if you rotate this, you will see that this A and A dash will be will be merged with each other. Clear? So that's why we do not take the horizontal, we do not take the second angle projection, because both frontal view and top view will be on the same place, means above the XY line. So it will create confusion for you. So always the top will be top view, and the frontal view and top view will be on separate places. Means if the top view is above, the frontal view will be below. If the frontal view is above, the top will be below. We will see it in a while. Now, this is another scenario. You can see this point A is behind the vertical plane, but it is below the horizontal plane. So if you are watching it from if you are taking its top view, so definitely you can see that this point, this is its top view. But when if you rotate the second angle, or if you rotate this horizontal plane, it will come to the upward. One more thing is that in this case you have seen that its top view is on horizontal plane, but if you rotate the horizontal plane, it will be above its top view will be above the XY line. And another one case. Now in this case you can see that the point A is behind the vertical plane, but it lies in horizontal plane. So if you are watching it from the top, so you will get this top view. But when this horizontal plane rotates such that it will coincide with vertical plane, so definitely you will get this top view which is above the XY line. So what we will draw conclusion is that if a point is behind the vertical plane, so definitely its top view will be always above XY line. And these are the three examples. In these three examples, you have seen that this point is always behind the vertical plane, so their top view will be above the XY line. Now let's discuss this also. Point within the vertical plane and above the horizontal plane. So this point is in horizontal plane, this point is in vertical plane, and it is above the horizontal plane. So in this scenario, if you are looking it from the top, so definitely you will project, if you project this point, it will lies on XY line. Clear? So its top view will be represented with A, but it will be on XY line. If the second scenario, if the point is below the horizontal plane and in vertical plane, so again its top view will be projected on this XY line. And if the point is in vertical plane as well as in horizontal plane, so in this scenario the top view will be again the same point, and it is represented by A and will be on XY line. So we will make a conclusion that if a point is in vertical plane, so its top view will be always in XY line. The position of top view of a point with respect to XY line is dependent on its position to the vertical plane only. So you have seen that the top view position of any point, that is dependent on the position with respect to vertical plane. If the point is behind the vertical plane, clear, so you will get the top view above the XY line. And if the point is in the point is again on XY line, or in vertical plane, so its top view will be on XY line. Now, the distance of top view of a point from X line is the same as distance of point from vertical plane. Now, what does it mean? So let's look at this example. So if this is the point, for example, this point A, that is, for example, 20 mm below the vertical plane. So you can see that this is the vertical plane and this is point A. So if this point is 20 millimeter behind the vertical plane, so you can see that if you want to project it on, if you want to watch it from the top, so you will get this top view. That is, this top view or this projection is again the same as distance from the vertical plane. So when you project it, it will, this line will, if you project it, this line will coincide with vertical plane, and this is the distance 20. So again, this top view is 20 millimeter above the XY line. So I hope you will get it. The distance of top view of a point from XY line is same as distance of point from vertical point. So we have discussed all these scenarios: position with respect to horizontal plane, position with respect to vertical plane, frontal view with respect to XY. And so if a point is above the horizontal plane and in front of vertical plane, so in this case, the front view will be above the XY line and top view will be below the XY line. Similarly, if a point is above the horizontal plane and behind the vertical plane, so what does it mean? It means that this is in the second quadrant. Clear? So its frontal view will be above as well as its top view will be above. So I hope this will be clear to you. If you are not clear, so we will have next slides which will clear your understanding. So you can see now this is the examples. So you can see the question is given: the point A is 35 millimeter above the horizontal plane and 50 millimeter in front of vertical plane. So first we will understand it by this. Now you can see you have been asked that a point 35 millimeter above the horizontal plane. So this is the horizontal plane and this is point A, which is 35 millimeter above the horizontal plane. And this point is 50 millimeter in front of vertical plane. So you can see. So if you project them, if you project A on vertical plane, so you will get a point that is A dash, which is the frontal view of this point. And if you are project this point A on horizontal plane, so you will get this top view. Now you can see that top view is 50 millimeter away from this vertical plane, and frontal view is 50 millimeter away from this vertical plane, and this top front view is 35 millimeter above the XY line. So whenever you will draw its projection, you have to draw them on vertical as well as on horizontal plane. Now if you rotate this horizontal plane, you can see these projections. You will not do this, but this is just for your understanding purpose. When you rotate this horizontal plane, like that it coincides with vertical plane, so you can see that this top view will be below XY line. So this point A shows its frontal view that is above the XY line and 35 millimeter above, and its top view will be aligned. Why it is line? You can see that if you rotate this horizontal plane, it will be aligned with frontal view, and this is the top view, which is 50 millimeter below the XY line. So that's how. Now this is the projection of the point that is mentioned in the example. So I will again repeat that a point, you have given a point A that is 50 millimeter above the horizontal plane, 35 millimeter above the horizontal plane, and in front of 50 millimeter in front of vertical plane. So you have been asked to draw its projection. So what will you do? You know that this point is 35 millimeter above the horizontal plane and 50 millimeter in front of vertical plane. So this is the first thing that this point is lie in first quadrant. Clear? So first thing you must understand that where this point lies. It is 35 millimeter above horizontal plane and 50 millimeter in front. So it's lie in first quadrant. The second thing is that this point is 35 millimeter above. So if the point is above the horizontal plane, its frontal view will be on vertical plane. So you have to draw its frontal view above the XY line. For that, you have to draw a line XY, and you will take 35 millimeter above and then draw a point. So that and annote it as A dash. This will be the frontal view. Now again at same line, you can see this is the 50 millimeter away from the vertical plane. So the point is in first quadrant, so its frontal view will be above the XY line and its top view will be below XY line. How much it will be below? It will be 50 millimeter because it is 50 millimeter away from the vertical plane. So you have to draw this vertical line, you have to draw a point that is 50 millimeter away from this XY line, and it will be represented with A dash, like this. You do not have to perform these things. These are just for your understanding purpose. So again, you have to do this. Here. So this was all about projection of points and its position with respect to principal plane. Here. So in next lecture, we will inshallah discuss the projection of straight lines. So again, remember that if you are clear about projection of points, then projection of lines will be easier for you to understand. So kindly clear all your confusions and get clear about this projection of points. If you have any question, you can ask me. Thank you.